Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue thinking about earth materials. So this video is going to correspond to section 4.6 of your textbook. So now we've begun to think about how geologists can identify individual minerals, we now need to start thinking about how geologists classify individual minerals. Now, being scientists, geologists will naturally want to take all the minerals we've got and will want to put them into separate groups, just because it's going to make them a little bit easier to deal with. So how do we do that? Well, we're going to start by looking at the periodic table here. So the periodic table, as you can see, consists of a couple of pieces of information. Obviously, we have the letter code for each of the elements. This is typically an abbreviation of the element's name. So for instance, cobalt is CO, nickel is Ni. This doesn't always hold true because some of the spellings which have been used to produce the abbreviated letter code are not based on the English name for that particular mineral. So a classic example would be tungsten. Tungsten is also sometimes referred to as wolfram, and that's derived from the mineral name wolframite, which is the first mineral from which tungsten was extracted. So that explains why in some cases the abbreviated letter code may not be consistent with the English spelling for that particular element. Now, the other piece of information that we have is referred to as the atomic number, and this is the number of protons which are present in that particular element's nucleus. So if you have an atom and it has 12 protons in its nucleus, it's going to be magnesium. If you have an atom and it has 52 protons in its nucleus, well, that element's going to be tellurium. So we actually define an element based on the number of protons it has in its nucleus. Now, when we look at the periodic table, we can see that it's split up into several distinct blocks. So over here we have what we refer to as the main group metals. In yellow we have the transition metals. In blue here we have the lanthanide series. In purple here we have the actinide series. Over here we have the noble gases. And then we have this block here, which is referred to as the P block. In here, in this kind of red color, we have the P block metals. And in here, in this green color, we have the P block non-metals, which are often simply referred to as non-metals. Now, when we look at the periodic table, there is essentially, a big difference which is relatively easy to spot. So the main group metals, the transition metals, the lanthanides, the actinides and the P group metals are often lumped together in one group, which we simply refer to as the metals. The non-metals, which are the green area here, refers to these elements here, and then we have the noble gases here. So there's three main groups: metals, non-metals, noble gases. Now, when we're describing minerals, the metals, so something like iron or cobalt, will often be relatively common. So there are lots and lots of iron minerals out there. So trying to use iron as a method of classifying, splitting minerals up into different groups isn't going to work particularly well because the group of metals you would end up with would be absolutely astronomical. The same thing goes for an element like potassium, for instance. There are loads of minerals that contain potassium in them. So if I try to split up minerals based on their potassium content, well, I'm going to end up with this huge pool of minerals that contain potassium, and it's not really going to do me much good. Now, the problem is that that situation goes for a lot of the metals. And so trying to classify minerals based on the metals which are in them is often not the way geologists want to go. So instead, geologists will very often classify minerals based on the non-metals which are present in them. So here we go. So in this particular diagram, you can see we have a portion of the periodic table. We obviously have a portion of the transition metals here. We have the noble gases here, and this block here, of course, is the P block. We have the P block metals here in red and the P block non-metals here in green. And what you'll notice is that some of these elements have been singled out, and these are the elements which we use to classify the minerals. We use to split minerals up into their individual, into separate groups, should I say. So the first group of minerals is a group of minerals called the silicates. So in the case of a silicate, we're going to have a metal, could be iron, could be potassium, could be sodium, and that metal is going to be bonded to what's referred to as a silicate group. And the silicate group could be SiO2 like we have here, it could be SiO3, could be Si2O6. There's some variability in how many silicons and how many oxygens you have, but the definition of a silicate though is a metal bonded to a silica group. The next group of minerals we have are the carbonates. So in the case of a carbonate, we're going to have a metal, could be something like calcium, or could be something like magnesium, and it's going to be bonded to a carbonate group, which is a CO3 group, and CO3 is exclusively carbonate. Okay, if I'm referring to a carbonate, I'm referring to a mineral that has a CO3 group in it. So whenever I see this in my minerals chemical formula, I know it's going to be a carbonate. The next group of minerals are the oxides. So this is where we have a metal bonded to oxygen. So that could be something like iron bonded to oxygen, or it could be something like copper bonded to oxygen. And the number of oxygens can vary. Sometimes it can just be one oxygen, sometimes it could be 2, 3, 4, etc. Okay, but as long as we have a metal bonded just to oxygen by itself, we have ourselves an oxide. The next group of minerals are the halides. And this is a group of minerals where we have a metal bonded to one of the halogens. So that's fluorine, chlorine, bromine, or iodine. Now, the vast majority of the halide minerals is going to be a metal bonded to either fluorine or chlorine. The classic example is table salt, which is a mineral called halite, which has the chemical formula NaCl. So it's 1 sodium and 1 chlorine. So the halides, as I said, it consists of a metal bonded to any of the halogens. So in theory, it could be a metal bonded to bromine or iodine as well. But in reality, fluorine and chlorine are by far and away the most common member of the halogen group. And so they are going to occur most commonly. So in the case of a halide, we're going to have a metal and it's going to be bonded to either fluorine or chlorine, and the numbers of fluorines or chlorines can vary. So, you know, we could have a mineral that has 1 chlorine in it, it could have 2, 3, 4, etc. The next element is sulfur, and actually we find sulfur in 2 different groups of minerals. So the first group we're going to think about are the sulfates, and this is where we have a metal bonded to a sulfate group, that's an SO4 group. And so a classic example would be something like calcium bonded to SO4. So we're going to have a metal bonded to an SO4 group, that's going to be a sulfate. Now, if we have a metal bonded just to sulfur by itself, that's going to be a sulfide. And a classic example of that would be something like pyrite, which is fool's gold, which is iron sulfide, FeS. The final group of minerals we have are referred to as the native metals. So these are metals that like to occur by themselves. The classic example, of course, would be gold. Gold is a very unreactive metal. It doesn't really want to bond with other elements. So typically gold is perfectly happy just to hang around with other gold atoms. And so this means you don't have a non-metal associated with the metal you're dealing with. So a classic example would be something like gold, silver, native copper, things like, native platinum, stuff like that. So as you can see, when we come to break our minerals down, we're going to split them into a number of different groups based on the mineral's chemistry. And by far and away the most common groups are, once again, the silicates, the carbonates, the oxides, the halides, the sulfates, the sulfides, and the native minerals, also referred to as the native metals. And so we're going to go into these groups in greater detail in the next presentation. Anyway, thank you for watching everyone, and have a good day.